Hi, everyone. I'm going to use this time to go over one of those exam problems for exam 3. This one is an exam problem from fall 2017, and I've modified it a little bit, so if you go pull down the PDF for it, it won't exactly look the same, but it's just a superficial difference, and I'm sure we can handle it. So let me pull that up. Here we go. Let's read it together. In this problem, you'll define a class to represent an order for a meal. Your class should be named meal order, and you should define the methods below. Hint, if you're using the print or input functions to implement these methods, you're doing it wrong. You do not need to write any doc strings. So these are nice directions that have been common to exams over the past couple of years in this class. If you're taking my class, you'll probably see the same directions on our exam. And let's go through what is available. So init is a method we need to implement. Add, contains, exchange, str, and give free. So if you haven't tried this, pause here and try to write the class for these. Okay, I'm going to assume that at this point everyone has tried this. So let's go over a possible implementation. I'm a little space constrained, so it may be hard to put it all on one sheet. But let's start maybe with blue and say that this is a class, and so we need to start with the keyword class. And then the name of the class, which is given as meal order. Okay. Now, inside the class, we have these methods, and I really like to just kind of run through and make sure that the parameters and the basic shape of my class is set up. And this is kind of the way I triage these problems, to say, gee, let's put all of the things in place so that we at least have an idea of where we're going. We don't necessarily have to start implementing anything yet in terms of the guts of the methods, but we can start to say things like init. The init class is, the init method is a method of meal order. It's a function, method function, so we have to write def underscore init underscore, and at least takes one parameter called self. I'll have to actually read it to see if it takes more. Initializes a meal order object, takes one parameter. Okay, it takes a parameter name. So self, and then name. And then I'm not going to implement this quite yet, so I'm going to skip down a little bit. This is where an eraser comes in handy because I can't tell the future. I have no idea how complex it is. I guess I could read it and find out, but I prefer to move forward and just say, we have another method that we need to implement called add. Def add self, and now I can look over and say this takes one parameter, a string representing a food. Okay, so it takes one parameter, I'll call it food. Now I'll skip down the contains method. Self, def contains, and self. Now I'll look, contains, takes one parameter, a string representing food. Okay, so food. And then I'll skip and go to the next one, exchange. Okay, exchange is going to have our self parameter, it needs to, but it may have others. Exchange takes two parameters, the original item and the new item. Okay, orig, new. 2 parameters beyond the self parameter. I'm going to skip to a new sheet to say I need a str method, def underscore underscore str underscore underscore self, and I assume it'll look like every str method we've ever seen, where that's the only parameter it takes. So this is where I'm going to want to be clear about my indentation. This is the boundary of the class. This is the method functions that go inside of it. And so I'll want to make my other things line up with that. Okay, so def str, and then I also need a def give free with a self parameter, and then I'll actually look to see what else it takes. It takes 1 parameter, a string representing a food. Food. Okay. So these are the methods I had, right? I'll draw that red line on this sheet too. I guess I only had it on one sheet. Okay. So now I've basically got the shape of my class put in place, in the sense that like I have placeholders for all the methods. If I was doing development, I might throw the word pass into each of these, right? So that I could actually implement them one at a time and build up my class. But we're not on a computer, so I don't need to worry about incrementally making this runnable. I'll just start implementing the guts of each method one by one. So init initializes a meal order object. It takes 1 parameter, a customer name. Good, we have that in place. It saves this parameter in an attribute. Okay. It also initializes 2 additional attributes. One is the list of items that are part of the order. The other is the list of items from the order that are complementary / free. Both lists are initially empty. Okay, so I have to save name in an attribute. So let me make sure that I have my blue pen. I'll do self.name equals name. There, I saved the pass parameter name into an attribute, which I also called name. And now I need to have 2 additional attributes. The order is the list of items from the order, the list of items that are part of the order. So I'll just call it order. And it's a list, and it's initially empty. And then the other is the list of items from the order that are complementary or free. So complementary is long to write, and free is relatively short to write, so I'll call it free. Self.free is a list that is initially empty. I'm now done with my init method. I don't think there's anything it asks me to do that I have not done. So I'll go on to implement the add method. Add takes 1 parameter, a string representing food. We already did that part. This adds this food to the order. Okay, well, our order is represented by the attribute self.order. So if I wanted to add a food to that list, right, it's a list, I use append. That's how we add things to lists. Append does not have a return parameter. This method doesn't seem to have a return parameter. So I am just going to say self.order, that's the name of the list, .append. And I'll pass append food. So now food just went into the list that lives inside the attribute self.order. It's a little funny, all those periods in a row, self.order.append, but it totally makes sense. The logical grouping is as if we put parentheses here, right? Self.order, that's a list, and we're appending to the list. But the parentheses aren't needed. Okay, I'm done with add. So I'll move on to exchange. Exchange takes two parameters, the original item and the new item. Oh, I'm skipping contains. I'll go in order. Why not? Contains takes one parameter, a string representing a food. Okay. It returns true if the food is part of the order and false otherwise. So our goal is to look through the list self.order and see if food is in there. And if it is, then return true. Okay, so we have many patterns in which we could do it. I'll do one pattern that we could go through the list using a for loop and look for it. And if we find it, then we can return the value true. And then if we don't, we return the value false. And so that would look something like this. We could use either of our for loop patterns. We could either iterate over the indices or we could iterate over the elements. I don't really need the index in my calculation at all, so I'm going to choose the iterating over the elements pattern. So for f in self dot order, if f is equal to food, then I'll return true. Now this is where I'm regretful that I didn't give myself enough space. So I'm going to give myself some magic space. And so if I go through the for loop and I don't find food, if I don't return, I want to return false. I don't want to say if f equals food, return true, else return false, because all that would do is conclude that food isn't in the list after having looked at the first thing in the list. So if my list is like soup and toast, and I'm looking for toast, right? I'll iterate through and pick up soup and say, is soup equal to the thing I'm looking for? It's not. Well, I guess toast is not in the list, but it would be the next thing. We would not look far enough. So I want to look through the whole list before I conclude it's not in there, which is why my return false is after I have gone through the full for loop. Okay, this is a pattern that is really within our ability. And there's so many variants of this pattern. Now, it turns out that there is some syntactic sugar that we covered this semester that would have made this even easier, and I'm going to write it on the side here, that we could have instead replaced all of this logic with this. Return food in self.order. Because this is a Boolean that will check to see if food is inside the list self.order. And if it's in, then it'll return true. And if it's not, it'll return false. And let's just very quickly pull up Python tutor to like double check that, right? Just to convince you that that works and also to convince me. So let's say we have a list and it has soup and toast. And I'd say print the value of toast in L, that it returns a Boolean true. And if it was something else, like sandwiches, it returns false. I'm actually going to pause the recording to see if that actually recorded or not, because I switched desktops and I'm not quite sure. No, I'm fairly confident it recorded. Where is my desktop again? Okay. So that's some fun little syntactic sugar that we could have done this in one line, but I wanted to present a much more reliable pattern in the sense that I am positive we've done this other pattern multiple times in the class and is very accessible to us to reason about. Whereas that syntactic sugar wasn't something that was emphasized. So that is the contains. If I pick out something in the order and it is equal to the thing we're looking for, then this func method is returning true. And if it's not in that list, then this function returns false. So let's go on to exchange. Exchange takes two parameters, the original item and the new item. If the original item is part of the order, it changes it to be the new item. The original item is no longer in the order, and the new item is in the order instead, and returns true. If the original item is not part of the order, then nothing in the order changes and the method returns false. Okay, so there's a method that we have that seems useful here, the contains method, that tells me if it's in there or not. So let's look at this. It says if the original item is not part of the order, then nothing in the order changes and the method returns false. That sounds like really easy functionality to do. Let's do that first, right? I can check to see if something is not in the order. Contains does that for me. So I could use the contains method. If self.contains orig equals false, this would be the contains method had returned false, then I'm supposed to do nothing and return false. Good. So now anything I write down here will only have happened in the case that the item called orig is actually inside the order. Right? And so our goal now is to find it and change it. So we have to iterate over the list and modify something in the list. So in this scenario, it will have been useful to use that for loop pattern that iterates over indices. Remember, we need the for loop pattern that iterates over indices if we want to modify lists. We want to go to the list at that index and change something. Right? That was the big difference between iterating over elements and iterating over indices. So here I want that other type of pattern. So for I in range len self dot order. For I in range len self dot order, so we're going to iterate over the entire list. This is where I need to, I'm writing a little big. I want to give myself a little room. I'm going to sneak it out of all these little gaps. That I made unnecessarily. Sorry, while I do this housekeeping. Okay, so I'm iterating over every index, and then I want to grab the element at that index. If self dot order at index I is equal to orig, if I found it, then I want to change it. I want to change it so that it's the new element. Self dot order I equals new. I don't really know what I'm supposed to do if there's multiple things in the list that match orig. I don't know if I change the first one or all of them. It really doesn't say. Like, what if this list is like apple, pear, apple, apple, banana, apple, and then I'm asked to change apple to pineapple? Am I supposed to change all the apples? I'm going to assume I'm supposed to, but I don't know. So it's ambiguous. I might raise my hand and ask. Like, what if the element is there multiple times? What should I do? That depends on if I wanted to return true right now, right? If I want to change the first element and if I just want to change the first apple to a pineapple and leave the other apples, I would put return true right now, the moment I found that first apple and changed it. Alternatively, if I wanted to change all the apples to pineapples, that's what's being asked, then I'd put it here, outside, after the for loop. And it's underspecified. Let me reread it to make sure it's underspecified. If the original item is part of the order, it changes it to the new item. The original item is no longer in the order. Okay, so I think I have to change all of them. Okay, so I have to wait till the end and return true here. So I've gone through the whole list, and every time I see apple, I've changed it to pineapple. And then when I'm done looking at the whole list, then I return true. Right. I mean, that's a reasonable interpretation, but if you were confused, so was I, and I'm still not quite sure. But I'll go with this. It's easier, or I might ask a question. So we've done the init, the add, the contains, and the exchange method. Let's go on to my other sheet and do the str method. So the str method returns a string that represents the order. For example, if the order attribute holds the value, the list holding the strings apple, pizza, milk, then this method returns the string apple, comma, pizza, comma, milk. All right, if the order attribute is the empty list, this method returns the empty string. So if I just return the string representation of self.order, it'll have those braces in it and those quotes. It will look like this first thing here that I'll underline in green. Oops, except I'm drawing on the wrong board, I think. It'll look like this thing that I'm circling in green. That's what it looks like if I just took self.order and turned it into a string. That's actually pretty close to the answer. But we can't modify strings, so I can't turn it into a string and then kind of fix it. I have to instead, because strings are immutable in Python, I have to build up the string that I want from the very beginning using one of those string accumulator patterns that we've described previously, right? Where let's say I want to build up the string S. So I would start off with the empty string, and then I would put things into that string. I would append things into that string. Okay? And then when I'm done, I would return it. So here's a first try, right? I'll just do something very naive, like for f in self.order. I'll do s equals s plus f plus a space. Okay? So that would mean that if I have this string, it would produce apple space pizza space milk space. That's not quite what was asked for. What was asked for was this. Apple, comma, pizza, comma, milk, and there's no space at the end of that string. So you could think, well, I'll put a comma here, comma space. Well, that'll produce apple, comma space, pizza, comma space, milk, comma space. That's pretty close. We still have that problem at the end. So it would have been helpful to be able to recognize if there's more stuff at the end. There's a couple ways to fix this, right? This is a string, so we could do slicing, right? We could say, all right, S is pretty close, but I always know that it'll have 2 characters at the end that I don't want. So I could just return S up to, but not including, -2. That only works if my list isn't empty. So, I don't know. I would want to deal with the edge cases. I'm a little uncertain about it. It may have been better to have checked to see if I had more stuff in my string. And to check that I have more stuff in my string, it's helpful to know how long my string is, how long the list is, and how many things I've processed so far. So in that case, it may be easier to use the index, the iterating over the index pattern. Okay, so I'm going to go back a little bit and say let's iterate over this in a slightly different way. Still using the idea that we started, but sort of now I'm regretful that it's not so easy for me to reason about the ending. And so I'll again start with the empty string, and I'll say, instead of for f in self.order, I'll say for j in range len self.order. So now I'm iterating through all the indices in the order list. And I'll say s plus equals self.order j. And if I have more stuff in my list, so if j is less than len self.order, I will also add to the end of that list the comma and the space. So let's run through it to see if this works, because we always have to check the edges. There's always little one-off errors. So let's trace our own code and see if it makes sense. So again, let's use this example, apple, pizza, milk. So we're saying for j in range len self.order. So the len of self.order would be 3. So j is going to take the value 0, then 1, then 2. Okay, and so s starts out empty. S starts out empty. And then the next time when j equals 0, we're going to go through this loop and we're going to concatenate to the end of s, self.order 0. So that's apple. So this just went from the empty string to the string apple. And then this comparison is saying if j, which is 0, if 0 is less than 3, well, 0 is less than 3, so we're going to change apple to apple, comma, space. Okay, and now j is we're going to go through the loop again. J is going to become 1. And so now we're going to concatenate to the end of apple, comma, space, the word pizza. So this becomes apple, comma, space, pizza. And then we're going to check again. If 1, j is 1, is less than 3, we're going to concatenate to the end a comma, space. So now our string is apple, comma, space, pizza, comma, space. And then j2, we're going to, apple comma space, pizza comma space is going to become apple comma space, pizza comma space, milk. Then we're going to check if 2 is less than 3, we're going to, we are going to add that comma space to the end after milk. We don't want that. So it looks like this check should have been something like if j is less than len self order minus 1. That way, we don't add it on the last one. There. If j is less than len self order minus 1. So if j is less than 2. So this time, when j is 2, we'll have previously apple comma space, and then we added a pizza comma space. And now j is 2, so we're adding milk. But then we say, is 2 less than 2? No, 2 is not less than 2. So we don't add that last part. All right, so this logic looks like it's building up the correct string for us. Always go back to your tracing skills. That's one of our core skills that we practice daily. I do have to remember, though, to actually return the value. Right? After the for loop, I'll return that s that I built up inside the for loop. All right, so I started with an empty string, and then I had a for loop that built up the string, character by character, by putting alphabet blocks together with that plus sign. And I had to think through it. It was not as trivial as just turning the list into a string and returning that, because it wouldn't have looked the same. Now we can think through what happens if we give it, if self.order has nothing in it. So s is the empty string for j in range len 0. So that does not even loop even once, right? Because whenever we have a number fed to range, it doesn't go up to that number. So if we feed range 0, then the factory, the iterator that takes numbers out and puts them into the variable j, nothing even comes out, not even a 0, because we're going up to but not including 0. So a 0 doesn't come out. So this loop doesn't even loop in the case of an empty list. So when we get down to here to return the s is still the empty string, which is exactly what we wanted. Okay, so our last method, this takes a long time when I talk through and variance. Okay, the last method is the give free method. This takes one parameter, a string representing a food. Yeah, we did that a long time ago. Okay, self food, good, still looks good. If the food is in the order, well, we could reuse the contains method to figure that out. Then it adds the food to the list of complementary items. Oh, finally, we use that free list. We haven't done that before. If the food is not in the order, then it adds the food to the list of complementary items and also adds the food to the order. Oh, we have so many functions here to support this. We have the contains function that tells us if something is in the order. We have the add item that adds it to the order. Okay, so we want to do something like this. We want to see if it's in the order. If it is, then we just add it to the list of free items. So if self.contains food, you could say equals true, or we could just say self.contains returns a true value, so we can just make our if based on that true value. If self.contains is true, then that means the food is in the order, so we want to make it free. So our attribute holding the free list is called free, and we want to put the food into that list. So self.free.append. There we go. Else, right, this is the case that self.contains food wasn't true. So we don't have the element yet in the order. We want to give them free pizza, but they didn't even order pizza. So we have to say self dot. Now we could say self.order.append, sure. We could also say self.add. One's not better than the other, but I'll demonstrate, right, how we would call add. We'd do self.add, and then we would pass it the parameter, right? Add takes one parameter. Self.add food. We'd also have to make it free. Self.free.append food. Does this return value? Does it return anything? If the food's in the order, then it adds the food to the list of complementary items. If the food is not in the order, then it adds the food to the list of complementary items, and it also adds the food to the order. So you can see that I don't need a return statement. It doesn't say that there's a return value for this method. You can also see that I did this a little inefficiently, right? This and this are the same line. So I could have rewritten this with less lines of code in order to streamline this. For example, I could just say, if not self.contains food, self.add food, and then after that, just say self.free.append food. That would cover both scenarios. But I think this is straightforward. This is kind of what I would expect people to do. They're kind of reading it and implementing it based on this description. But there are lots of options. Okay, so now we have made the order class, meal order class. I spread it across 2 screens, so you may want to pause and review it before we move on to using the class. So, okay, this is us moving on to using it in the next part of the problem. So I'm going to hide and show this one. This is using the class. For this problem, you must write a complete program. Okay, well, I am not going to do that in this review, but I'll mention that a complete program requires you to have imports. Well, okay, I'll do it. I'll do it as we go. So for this problem, you'll write a complete program. This includes logic in def main, a call to main, any necessary library imports. You do not need to write any doc strings. That's nice. Okay, so I don't need to write a program doc string. That's different, but that's what it says. I definitely don't need to write method doc strings. You do not need to write any doc strings. Well, that saves me some time. Where's my pen tool? Am I writing on the wrong? Oh, I know what's happening. There we go. That's what I was saying. Okay, you do not need to write any doc strings. That's neat. To earn full credit, you must use the methods from the meal order class whenever appropriate. You may assume that the class, as described in problem 5, has already been correctly implemented for you. So if you did not understand how to implement a method, or if you are worried that you did it wrong, or that you know that you did it wrong, forget about it. That's in the past. All you need to do is remember how it was described, how it should have been, how it should work, and make use of that, right? So I could effectively have skipped that problem and done this first, as long as I had gone back and read it and knew what those methods were and what they did from a user's point of view. Okay. Your program helps run the kitchen on a pirate ship. It should do the following. Define a function called getOrder that does the following. So I don't like following the directions. I haven't read everything completely before I've started, but I know that I just should start by making a function called getOrder. It's a weird name. It looks like a class name because of the capitalization, but I'll roll with it. I was told what to call it. It's not my choice. Remember, we are not in a class. This is not a method. This is a normal function. Starts with def, has the function name, has parameters. There's no self parameter. We're not in a class right now. We are using a class. We're not building a class. So define a function called getOrder that does the following. Prompts the user for order information. Okay, so we're actually interacting with the user, so we need to use the input function. This information is a string that is the pirate customer's name, always 2 words, followed by an order, any number of 1-word food items. Okay, so I don't know how much they're going to type. They're going to always give me, well, okay, we'll keep reading. A 2-word pirate name followed by an order, any number of 1-word items. For example, Deadeye Pete order has 3 items. Deadeye Pete, meat, rum, sea biscuit. Okay. If the user string is empty, the function returns none. All right, so far I haven't seen anything about parameters that this function takes. It sounds like it takes no parameters. So I'm going to close this parentheses and do a colon. We have to prompt for user information. So I'll store it in something like this is called order, or maybe I'll call it something else. Info. Input. There is no example so far of an interaction for what it looks like for me to get the information from the user. So I have to invent that myself. So I'll say enter order info. And this comes back a string, which is what I want. It'll be a string like this. This is what info could be. And so it prompts the user for order information. I did that. This information is a string, yes, -2. That is the pirate customer's name, always 2 words, well, I don't know how to ensure that. So if I keep going, we see there a bunch of info that I have to look at. So, okay, if the user's string is empty, the function returns none. Well, I know how to do that. If info equals the empty string, return none. I'm going to write some guidelines in. Because otherwise, my indentation is going to be all over the board. Okay. If the user string is empty, the function returns none. All right, I did that. If the user string is too short to be a valid order, the program exits with some error message. The shortest valid order is 3 words long, like Red Hand Jane rum. Okay, so this is where I need to think of taking a string and turning it into pieces where those pieces are words, where we defined a word by there's a space or something between them. So we know that that's our friend split. So we would have something like L equals info.split. Right? Info is the string, split is a string method that has a return value that is a list. And so now I have to say if the user string is too short, so if the len of L is less than 3, we have to exit. So I have to do something like sys.exit. That means I need to import sys, right? We're writing a complete program. I have to do the imports. Sys.exit too short. That's fine. So there we go. I've checked to make sure it's not too short. Otherwise, the function creates a meal order object using the pirate's name and populates the order with the foods that were just listed. Okay, so I need to create a meal order object. So M equals meal order. And the meal order object is supposed to take a name. But I think the name is supposed to be one string because it's only one parameter that represents a name. It's not a first name, last name. If we go back to the meal order description, it takes a name, a string. Well, I'm stuck with the pirate name that's now split. Like L0 is Red Hand and L1 is Jane. So I have to put them back together again and pass that as the parameter. Right, so I could do that with a variable, or I could do that without a variable, but I'll do it as a variable because I think my experience is that students like to see these things divided into little steps that they can reason about more easily. So let's say name equals L0, that's like Deadeye, and then a space between the first and last name, and then L1. Okay, so that's Deadeye space Pete. And then I pass the name during the initialization of the meal order. Great. So I've done this. Creates a meal order object using the pirate's name. Now I have to populate the order with the foods that were listed. Well, I know that the pirate's name is exactly 2 words, right? L0, L1. So I want to basically iterate from L2 to the end of the string. So I have a for loop pattern that lets me decide to start the for loop at a certain place and end the for loop at a certain place, right? That's the for loop that has 2 parameters. So I could do for j in range starting at 2 and going up to len of L. So if the pirate wanted to order 3 things, then like this, Deadeye, Pete, meat, rum, Seabiscuit, the length of this is 5. So this would be range 2, 5. So that means the indices would be 2, 3, and 4. And those are exactly the indices for meat, rum, and Seabiscuit. So now I can just add those to the meal order. There's a method for that, right? Add. So I can do M, that's the name of our meal order, dot add LJ. Right? LJ would be L2 is the first thing. So that's the meat over here. If we think about this list, right? This is Deadeye is 0, 1, 2, 3, 4. So L2 is meat, L3 is rum, L4 is Seabiscuit. All right, so now I've done that bullet. The function creates a meal order object using the pirate's name and populates the order with the foods that were listed. Good. If the customer has Deadeye in any capitalization as their first or last name, then they get free rum and free turtle soup. Okay. So I need to say, if L0 dot any capitalization, so it's easier just to take their name and make it all lowercase. If L0 dot lower, right? That's a method, so I need to call it like a method function, equals deadeye, or L1, right? Their last name is still in my L list. L1 lower equals deadeye. Then I want to give them, so this is, we have a method for this. Let's go back. The method for this is give underscore free. It takes one parameter. And either give free. It will, if they've already ordered it, it will make it free for them. If they haven't ordered it already, it'll add it to their order and make it free for them. So that's useful here. M dot give free. So what am I giving free? Rum. It takes a string, not a list. So I need to call it twice. One for the rum and one for the turtle soup. If the customer has Deadeye in any capitalization as their first or last name, then they get free rum and free turtle soup. Okay, I'm reaching the bottom of my page, so I have to switch to another layer. Let's give myself similar lines on this other layer. This is where I am. This okay, so this is my new layer. Ooh, looks like I drew this on the wrong layer. Sorry about that disorganization. Okay, so where was I? We were here. Every order on the pirate ship must include either rum or grog. So I'm going to continue. I'm still inside the get order method. And now I'm dealing with the fact that every order on the pirate ship must include either rum or grog. If the order lacks these, then add grog to the order by default. So we have the contains method to check if something contains something already. So if it's not the case that the order M contains rum, so if it doesn't have rum and it doesn't have grog, then we have to add grog by default. So if it doesn't have rum and it doesn't have grog, alternatively, I could have said if it's not the case that it has rum or it has grog, right? I could have used De Morgan's to flip the logic a little bit, but this is okay. So I've done that. Every order on the pirate ship must include either rum or grog. If it lacks these, then we added grog by default. Finally, the function returns the meal order object. Okay. Return M. That's the last part of our logic. For a meal order. So just to summarize, Def meal order goes from here all the way to here. So let me get a little eraser to show. That I'm going to have to write a new function soon. Define a function called get all orders. That would be back here. Def get all orders. That does the following. Repeatedly calls get order. Doesn't sound like there are any parameters passed. It repeatedly calls get order until it returns none. Adds each of the returned meal order objects into a list and then returns that list. Okay, so I'll have to make a list that is initially empty. I have to get a meal order object by calling the get order function. Didn't look like I passed anything to it. It took no parameters when I looked through the description before. If m is not equal to none, repeatedly call get order until it returns none. So I want to do this repeatedly. So not just if's just for one time. Let's do while. While m is not none, we're going to put that meal order into our list, and we're going to get another meal order. And then I'll go back to the top of the loop and say if that was none, then add it, get the next one. We're going to keep going. So the first time it returns none, we stop this loop, and we would want to return the list of meal orders. That's a very simple while loop pattern that we've used before. Okay, sort of a sentinel controlled while loop that is searching for the sentinel. In this case, the sentinel is the thing that signals that we don't have any more meal order objects to add, and that sentinel is none. So we get the first one, we check the sentinel, we do something because we haven't reached it, and we get the next thing. We check the sentinel, etc., etc. That was a very straightforward while loop. So now, main. We're going to do these things. The first thing in main is call get all orders to get a list of all the orders. Okay, so orders equals get all orders. So orders is a list. That's what get all orders returns. It's either an empty list or it's a list with stuff in it. Right, it calls get order for us. So good, call get all orders to get a list of all the orders. Using the orders, make a list of just the orders that include meat. Okay. I have to make myself some more room, I think. I'm gonna push some of this up a little bit. I'm writing a little too big. So I am looking for all the orders that have meat. And I'm making a list of those orders. So that's the list accumulator pattern, where I would say meat starts out as an empty list, and for O in orders, I'm going to look through all the orders and say if O dot contains meat, right? That is the method that tells me if that order has meat. I'm going to put that order, right? Meat here is the string. I'm not going to, In case it's confusing, I'm not going to call my list meat. I'll call it capital M. Okay, capital M. But now it's confusing because it looks like my indentation is off. So let's move this sucker over. Okay, capital M dot append O. So if O has meat in it, then we're putting O into M, the meat orders. So we've done this. Using the orders, make a list of just the orders that include meat. I think I'm going to be running out of space. So this is where I'm going to reuse this. This had the problem for the class writing thing. Okay, here we go. Okay, so this is what we started out with. We started writing the get order function, and we did all of that, and it spilled out a little on the top here. Then we did the get all orders, and we did a lot of that, and then we started the main, but I'm running out of space. So the main is going to spill back over onto this page. So let me continue my lines. This will be outside of def main. This will be inside of def main. And so here, this was my for loop. And so this red line is outside the for loop. Okay, so up here is outside the for loop. We have done this already. We've made a list of all the orders that just contain meat, and now we're working on this. There's only enough meat for the first 20 orders. The remaining orders need to be modified. For these, exchange meat for slop. Okay, so I don't really know. I'm going to assume that, so the list M, capital M, has all the meat orders in it. So I'm going to assume that that is larger than 20, right? There's only enough meat for the first 20 orders. So I'm going to loop over all the meat orders, but I'm going to skip the first 20 because it says they can still have meat. The remaining orders are the ones that need to be modified. So for these, I'm going to exchange meat for slop. There's a method for that, I think, right? There's an exchange method where I have the original and the new. For each changed order, add complementary rum. There's a method for that, give free. Right, so exchange. This is give free. This is exchange. In each case, print a summary of these changes, including the old and the new order, and pirate name, matching the below format. So when we change something, an order into a string, it would look like this green thing, right? And so if I can print the order before and then the order after, okay, so first I only have to modify the orders in our meat list that start at index 20, right? Because the ones at index 0 to 19, they can all still have meat. So I'll say for I in range 20 to len of capital M. And this will let me iterate over all the indices of the meat list, skipping the first 20. And now I would want to take that order. I'll say that order is O. That's M at index I, order O. And I'll want to exchange meat for slop. And as an apology, we add free rum. And now I have to print out summary info, but I've already modified it. I've modified the order. So I've now forgotten the old order. So I need to do that before I change it. So this line, print order for Annie Bonnie was changed. So I need to do something like print order for, and then the name, which I think is in the attribute order name. Order for Annie Bonnie was changed. And then I want to print the word from colon, and then the order, because when I print the order itself, it'll use the str method to change it to a string first, and it will give me this green thing that I circled. And then I change it and I add free, and then I can print the remainder of that line, 2 colon, and then I'll print the order again, because now it's changed, right? I changed it in these 2 lines. So now when it prints, it'll change, meat will be slop and grog and turtle soup, and then I've added rum to it, that's free. And I look to see if there's more stuff I have to do, and there isn't. And so that did it. That modified all my objects. I think I've satisfied all of the requirements. So let's, go back and use our tracing skills to review, make sure I didn't use any libraries that I forgot to import. Oh, right, it's a complete program. So I've forgotten something. This is what I've forgotten. An actual call to main, so the whole thing runs. I think I'm done. So we defined get order. That actually got a single order and made an object. This is a very common pattern. I'm sure that on the exam, when you use the class, there will be some function whose main goal it is to get something from the user and actually create one or more objects. And then get all orders was just a function that repeatedly did that and put them into a list, our primary data structure in this class. We love putting things in lists. And then main, that actually called those functions. So it called get all orders, and then it did something, did some business logic. And in this case, it was saying, oh, I have to change all the orders. So I first looked through all the orders, and if that order had meat in it, then I put it into the meat list. And then I looped across the meet list, picking out the people that need to have their order changed, grabbing the order, printing some information about it, modifying the object, printing out some information about it. Right, and I looked back over to make sure that I was using the methods that seemed natural. So there was an exchange method and an add free method. There was not a method like get name or something. So I had to actually use the attribute here. I couldn't figure out a way to get the name out of the object. There wasn't a method that gave that to me. But here I'm implicitly using the str method. And then here I'm using the contains method. Here I'm using the add method and the contains method. I'm using the init method when I call, oops, no, that's inside here. I'm using the init method when I create the get order object. I'm using the add method. I'm using the give free methods. So I think I'm using the methods as they were described correctly. I'm using them in all the places I can think of to use them. So that's it. I hope this was helpful. I hope if anything is confusing, you try it out on Python Tutor and then maybe ask a question if it's still confusing. But thank you. Good luck.